Hello grade 8 students, welcome to the YouTube channel Maths for You. Today I am going to teach you the lesson Symmetry in grade 8. In your textbook, that's chapter 11. In grade 7 you done this kind of things. It means symmetry. Under symmetry you learned bilaterally symmetry, likewise that. So in grade 8 also have same lesson. Now we are going to do symmetry. Let's see what are new concepts with symmetry in grade 8. Bilaterally symmetry. Earlier you done that one. Let's see. You learnt in grade 7 that if it is possible to fold a plane figure through a line on it to get two identical parts which coincide with each other, then it is called a bilaterally symmetrical plane figure. Here, can you see? Here one symmetric axis, here more symmetric axis, only one, likewise that. You done in grade 7 that kind of things. You also learned that such a line of a bilaterally symmetrical figure is known as an axis of symmetry of the figure. Here, can you remember? Grade 7 you done this kind of things. It's good activity. Using ink. Here, in our nature we can find many symmetrical plane symmetric images. Here, it's a leaf. You can see here this is look like symmetrical axis. Can you remember lines of symmetry? Here, square, 4 lines of symmetry. 1, 2, 3, 4. Rectangle, there are 2 lines of symmetry. Rhombus, 2 lines of symmetry. If you get a kite, yes, you can. Here, they have only one symmetric axis. Isosceles trapezoid, here 1. Trapezoid, no lines of symmetry. Here isosceles trapezoid, here trapezoid. Parallelogram, very important part. Parallelogram, no lines of symmetry. At least one, no. Equilateral triangle, here there are 3 lines of symmetry. Isosceles triangle, only one symmetric axis. Okay. The 2 parts on either side of an axis of symmetry of a bilaterally symmetrical figure are equal in shape and area. Here, can you see? Here this is the symmetric axis. Here this part and here symmetrical figure are equal in shape and area. Here this side and here other side also same. Same means same shape. Not only that, same area. From our nature we can get this kind of images. Can you see? It's our nature. It's amazing. Here, butterfly. Here, it's coincide. It means they have a bilaterally symmetry. In day-to-day life, we can see more symmetry images. Here, you can draw symmetry. You can get the symmetric axis. Okay, with our nature you can find many things. Okay, now this is our new concept. It's mean grade 8 concept. Rotational symmetry. What is mean by rotational symmetry? Let's see. When a plane figure is rotated about a fixed point in it through one complete rotation. One complete rotation means 360 degrees. If it coincides with the original position before completing one rotation, then it is said to have rotational symmetry. The point about which the figure is rotated is called the center of rotation. Here, this is the center of rotation. Okay, let's see. The number of times a figure that has rotational symmetry coincides with itself when it is rotated once about the center of rotation is called its order of rotational symmetry. Here you can understand that if it is not clear, you can understand from here. Here we have to find order of rotational symmetry. Now this is a rectangle. Start with this point. Here not the same position. Now here again here. So it's mean how many? Here answer order of rotational symmetry. Answer is 2. Because why? Here this is the starting point. Again not here. Up to here one rotation, again starting position again. So it's mean 2 rotational symmetry. It's mean order is 2. Let's see another example. Here square shape. Here what is the order of rotational symmetry? Here 1, 2, 3, 4. It's mean order of rotational symmetry answer is 4. Here finally coming to the starting point. Let's see here. Here order of rotational symmetry. Look at again. Starting with here 1, again 1. It's mean 2. Yes. If a geometrical plane figure which has rotational symmetry is also bilaterally symmetrical, then its order of rotational symmetry is equal to the number of axes of bilateral symmetry. A figure which is not bilaterally symmetrical can have rotational symmetry. Its parallelogram is a good example for that one. Not bilaterally symmetrical can have here parallelogram. It's mean parallelogram is not bilaterally symmetrical but have rotational symmetry. Finally you can understand that part. The center of rotational symmetry of a bilaterally symmetrical plane figure which has rotational symmetry is the point of intersection of its axes of bilateral symmetry. It's mean you can get that point from the intersection of its axes. If the order of rotational symmetry of a plane figure is 2 or more, then that figure is said to have rotational symmetry. Very important, 2 or more. Here, the order of rotational symmetry of a figure that has rotational symmetry is greater than 1. Greater than 1 means 2 or more. The order of rotational symmetry of a figure that has rotational symmetry is greater than 1. Here, can you see? This is a hexagon. Here, starting point. Now, step by step, you can get the order of rotational symmetry. 1, 2, 3, 4, 5, 6. Its mean order of rotational symmetry answer is 6. Here first one and last one. Here this is the starting point. Rotated 6 times back to starting point. Here both are same. So don't count twice. Here 1, 2, 3, 4, 5, 6. So order of rotational symmetry in a hexagon answer is 6, not 7. Don't count this one again. Using the yellow dots as the starting point, rotate the hexagon until it covers itself exactly once. Twice, 3 times, 4 times, 5 times, 6 times back to the starting point as demonstrated. Likewise this. Here normally rotational symmetry you can get here normally here triangle mean how many symmetric axes. Equilateral triangle there are 3 symmetric axes. So here rotational symmetry also 3. If you get a pentagon, how many symmetric axes? 5. So it's equal to rotational symmetry. Square shape, how many symmetric axes? 4. So rotational symmetry also 4. But always not, we can't get that. Because why? Here, let's check. Here plane figure they given equilateral triangle. Number of axes of symmetry. Equilateral triangle, can you remember? So how many number of axes of equilateral triangle? 3. Order of rotational symmetry also 3. Order of rotational symmetry. Have order of rotational symmetry mean it's rotational symmetry. Yes. Here parallelogram, can you remember, very important, number of axes of symmetry 0. Order of rotational symmetry 2. Here number of axes of symmetry 0 but have rotational symmetry. Here order of rotational symmetry is 2. Rhombus, number of axes of symmetry 2. Order of rotational symmetry also 2. It means have a rotational symmetry. Rectangle, number of axes of symmetry 2. Order of rotational symmetry also 2. So it means have a rotational symmetry. Square shape, number of axes of symmetry 4. Order of rotational symmetry also 4. It means have a rotational symmetry. Regular pentagon, it means 5 axes. Regular hexagon 6 axes. Regular octagon, number of axes of symmetry 8. Here number of axes of symmetry equal to order of rotational symmetry. So here 5 means here also 5. In a hexagon also number of axes of symmetry equal to order of rotational symmetry. Regular octagon also same. But we can't say always number of axes of symmetry is not equal to order of rotational symmetry. Because why? They have a good example for that one. What is that? Parallelogram. Parallelogram is the example for that one. Number of axes of symmetry is 0. Keep it in your mind well. Order of rotational symmetry is 2. But those are not equal but have a rotational symmetry. Have a rotational symmetry mean order of rotational symmetry. 2 mean have a rotational symmetry. Okay. Alright. Now I think it's clear for you. And try to practice a lot. You can improve your knowledge. Do your textbook exercises. And we can meet with another new chapter. Thank you.